All right, ECU warriors, welcome back to the Explainer. If you're running a shop or tuning full-time, you already know the deal. Modern engine control units are getting seriously locked down. So today, we're diving into some advanced workshop training to master an absolute must-have skill for your diagnostic arsenal: bench mode ECU reading. I mean, we have literally all been there, right? You've got a customer waiting, you plug your trusty tool into the under dash port, and bam. OBD reading failed, protocol not supported. It is incredibly frustrating, but hey, it doesn't mean the job is over. It just means we're going to have to elevate our approach. Okay, let's dive into this. Here's our roadmap for today's training. We'll be looking at when OBD methods fail, bench mode tools and prep, connection and ECU reading, bench versus boot mode, recovery and troubleshooting, and wrapping up with pro ECU best practices. Let's get to it.
All right, Section 1. When OBD methods fail, why switch to bench?
Look, OBD tuning is great. It's fast, it's minimally invasive. But let's be real, manufacturers are fighting back hard. They're deploying security gateways and TPROT, tuning protection, that actively blocks that OBD port. And that is exactly where bench mode saves the day. By pulling the ECU and making a direct pin connection, you're totally bypassing those OBD locks. You get a complete, unrestricted firmware read. Now, certain manufacturers are notorious for this, and they will absolutely force you to the bench. The Bosch EDC17, yeah, that's a classic example. Same goes for the newer Bosch MD1 and MG1 series. You almost always have to unlock those on the bench at least once before OBD even becomes an option. You're also going to see heavy resistance from Delphi, Denso, and Siemens Continental units. Moving right along to Section 2, bench mode tools and prep, the essential equipment. When you're working outside the car, your bench equipment is literally your lifeline. You absolutely need a premium interface. Think Auto Tuner, Magic Motorsport Flex, or your KTAG and KT200 setups. You also need quality bench harnesses and breakout boxes like the KTAG GT100 Plus to route those signals safely. But honestly, the real unsung hero here is a highly stable, completely clean power supply. Even a tiny voltage drop during a flash will instantly corrupt that ECU. And congratulations, you've just turned a $1,000 computer into a very expensive paperweight. Take the ECU Help PCM tool, for example. Tools like this are a massive game changer because they allow for cover-free, welding-free data reading. The advantage there is huge. Anytime you can pull data without physically cracking open that sealed casing, you are drastically lowering the risk of hardware damage. And this brilliantly illustrates a non-negotiable rule: protocol matching. If you're looking at compatibility lists for, say, Ford or VAG CMOS ECUs, you'll see you can't just guess. You have to meticulously match your tool's protocol to the exact ECU variant on your bench. Pick the wrong one? Best case, no communication. Worst case, you're writing data to the wrong memory sectors, and that is a total nightmare. So, how do we actually prep for this? First things first, carefully remove the ECU from the vehicle. Second, absolutely verify your variant using the physical sticker data. Cross-reference the year, the engine, the BHP. Don't just trust what the customer told you. Third, set up an anti-static workstation. A tiny static shock can literally fry a microprocessor. And finally, get your breakout box and diagnostic tools securely connected before you even think about applying power. Okay, Section 3, connection and ECU reading. Actually extracting the data. Every single bench setup relies on a few critical communication lines. You're always going to need power, usually 12 volts, and a solid ground. Then you've got your network lines, CAN high and CAN low. And depending on the specific module, you might also need boot or multi-pin connections. Guys, triple check those colored pinouts before flipping that power switch. Seriously, measure twice, power once. Now, what's really interesting here is the architecture of the data you're pulling. You've got your flash or micro read, which contains the main operating firmware and those all-important engine performance maps. But then you have the EEPROM. The EEPROM holds the immobilizer data, the VIN, and specific vehicle coding. If you mess up the flash, the car might run bad. But if you scramble the EEPROM, that car is absolutely not starting because the key recognition is just completely gone. Next up, Section 4, bench versus boot mode, the ultimate fallback. So what happens when an ECU is just completely stubbornly locked? Enter boot mode. This is your highest risk, highest reward fallback method. You physically open the sealed ECU case and connect directly to the microprocessor or memory chip using a BDM frame or some really precise soldering. It forces the processor into a low-level state and gives you total, unrestricted access to the whole shebang.
But let's be honest, opening a sealed ECU is a seriously nerve-wracking game of patience. You usually need to apply heat just to loosen the internal thermal paste, grab a T15 star drive to pull the safety screws, and then gently pry it to break the sealant. Actually, scratch that. Let me emphasize this. Never, ever just ram a flathead screwdriver inside to pop it open, or you're going to gouge the circuit board right in half. Once you're safely in, you just align your pins directly to the tiny communication dots on the board.
All right, Section 5, recovery and troubleshooting, because eventually things will go wrong.
Let's say you get absolutely no communication and the software is throwing red text errors at you. Stop immediately and re-verify your colored pinouts. What if you're seeing electrical anomalies? Glance over at the digital display on your breakout box. You're looking for abnormal current or voltage drops. And the absolute worst case scenario, you brick the ECU. If that happens, you better hope you have a backup. You'll need to use recovery services like FlashTech to generate a pristine 100% stock factory file to force flash back into the unit to bring it back to life.
Which brings us to Section 6, Pro ECU Best Practices, the golden rules for tuners.
So, the absolute crucial point from all this training, your backup is your one and only safety net. Always generate a complete pre-operation backup. Constantly verify your power supply stability, triple-check those pinouts before the power ever goes on, and validate all your checksum corrections. And keep the golden hierarchy in mind. OBD first if it's supported, bench second for full access, and boot mode, well, that's your absolute last resort.
At the end of the day, bench mode turns closed doors into wide-open opportunities. It is an absolutely essential skill. So, armed with the right tools and a bulletproof methodology, are you ready to tackle the complex ECUs that OBD simply leaves behind? Thanks for exploring this with us, and we'll catch you on the next explainer.